Okay, assalamu alaikum. This is the last video for 4.1, which is the central processing unit. And in this, we'll be going over the fetch execute cycle, right? So this is a very important part of this topic. It's asked multiple times. So we'll be going over this flowchart of sorts to go over the fetch execute cycle and how registers work together in order to fetch, execute, decode, and repeat, right? So as you can see, there's a start symbol here, and then we go on to this decision making box. The diamond is called the decision making box. We check if there are any instructions. So if there are no instructions, then you just go back. There are instructions, then we move on to these steps. So first of all, we move on to the step in the sense that the program counter contains the address of the memory location of the next instruction that has to be fetched. Like, so it contains the address of it, right? So what do you do when you have the address? So the address is copied from the PC to the memory address register using the address bus, right? So you have this address in the PC, you use the address bus to transfer that address to the MAR, which is indeed the memory address register. Now then we move on to the third step. So the contents at the memory location address contained in the MAR are then temporarily copied into the MDR, right? So you have this MAR. So you have the address here, right? So you go to this address and then these contents are copied, and these will be the contents, and these are copied into the MDR, right? So this is what's going on here, right? So you have this address, you go to the address, you get the contents, and then you copy the contents temporarily in the MDR, which is the memory data register. So the contents of the MDR are then copied into the current instruction register. So it's time for you to work upon this current instruction, right? That for the data which you have just copied, right? So the value in the PC is then incremented by 1. So this is in order to efficiently transition from one step to another. Like, you do not need to wait till the end in order to increment the PC, right? So while you're decoding this and performing stuff on this, executing this instruction which is in the CIR, you're incrementing PC to get ready for the next instruction, right? And the instruction is finally then decoded and then executed by sending signals via control bus to the various components of the computer system, right? So if it's related to components, as we have already read, we use the control unit and the control bus along with the system clock to have those components work along the instruction that we have currently, right? Then we have another decision box, and then we have any interrupts to service, right? So we'll be discussing the interrupts as well, right? And then if we have any interrupts, then we service the interrupt, and then we move on to the original any instruction decision box. If we do not have any interrupts, then we just move on to the starting, where we have move on to the any instruction decision box once again, right? So this is how our fetch execute cycle works in a nutshell, right? Now we moving on to the register transfer notation for the fetch execute cycle. So this is really important as well. So this is the register transfer notation that is currently present in our syllabus. There are multiple variations. It depends from the CPU architecture as well. So it's just the fetch execute cycle, but you need to be aware about these symbols and all this stuff that is being used, right? So as we just discussed, the contents of the PCs are copied to the MAR. So you're copying these, right? Then the PC is incremented by 1. So it doesn't really matter. It should be after step 1. So the PC is incremented after step 1 and it's simultaneously interrupted. So in the sense, putting it in a step is not really necessarily important, but you just need to be aware about it being between step 2 or 3. It cannot be at the last, it cannot be the first. That is it. And data stored at the address shown in MAR is then copied into the MDR, and the contents of the MDR are copied in the CIR. So this is just what we read above in the flowchart, right? And now we need to be aware about why we are using double brackets in line 3, right? So as you can see, there's single brackets in line 1, 2, and 4, but there are double brackets in line 3. So why is this the case? So double brackets are used in line 3 because it is not the MAR content. So the MAR contents are just an address, right? But the stuff that is being copied into the MDR is the contents at the address which are stored at the MAR, right? So that is why we are using double brackets in this case, right? So now we move on to interrupts. Okay, so what is an interrupt, right? So an interrupt is a signal sent from a device or from a software to the processor, right? So this causes the processor to temporarily stop what it is doing and then to service the interrupt, right? And mostly, as you just saw in the flow chart, after the fetch execute cycle is done, right? So this fetch execute cycle is being executed. At the end of the fetch execute cycle, you check for any interrupts. If there are any interrupts, you service them and then move on to redoing the fetch execute cycle, right? So a question that occurs a lot of the time in the examination is how interrupts are handled during the fetch execute cycle. So I'm just writing a simple answer to it. It usually comes for 4 to 5 marks. So this is really important in terms because the paper is out of 75, and if you can score these 5 marks, you're well and good. So at the end of the fetch execute cycle, the processor checks for interrupts, as we just saw in the flowchart as well. The computer is checked for an interrupt flag. So here is an interrupt flag which indicates that there is an interrupt. So the processor then identifies the source of the interrupt and then checks for the priority of the interrupt. So you check the priority because if your computer is doing a very important task and the interrupt isn't that important as compared to the task, so the interrupt is temporarily ignored. But if the interrupt priority is above the current task, then the processor saves the content of the current registers, meaning the MDR, MAR, CIR, PC, right? And then calls the interrupt handler which services the interrupts. Okay. So when the service is complete, the contents of the register are restored and processor continues with the fetch execute cycle. So this is just a very basic outlook of how the fetch execute cycle after the fetch execute cycle, what happens if an interrupt is done. So today we read about the fetch execute cycle. We discussed this flowchart. Then we discussed the registry transfer notation, and we discussed why double brackets are used here. And then we went on to discuss the interrupts, which is a very small topic, and you just need to be aware of how interrupts are handled after the fetch execute cycle, during the fetch execute cycle. So it is pretty much that, and this marks the end of chapter 4.1, which is central processing unit, right? The CPU. Thank you so much for watching.